In this video, I'm going to be introducing the concept of elasticity, an economics concept, specifically price elasticity of demand. So in economics, one of the most fundamental ideas is the law of demand. And the law of demand states that as the price of a good or service increases, the quantity of that good or service that will be demanded by the public decreases. So they are inversely related. If the price comes down, the quantity demanded goes up. If the price goes up, the quantity demanded goes down. This is most easily represented through a graph, a downsloping graph, such as the one that we see here. So we can see from this curve that when we have price, which is on the vertical axis, when price is really high, like up in here, then the quantity demanded is very low. But as the price decreases, as we see over in this part of the graph, the price is very low on the vertical axis, but the quantity demanded is high. So some type of a downsloping curve will represent the law of demand. Well, elasticity tries to quantify that. And so elasticity can be defined as the percent change in the quantity demanded for a given percent change in price. So let's just start by saying that elasticity is going to be equal to the percent change in quantity demanded divided by the percent change in price. And so a percent change in quantity demanded can be represented as the change in the quantity divided by the original quantity times 100 divided by percent change in price, which would be the change in price over the original price times 100. Well, the 100s cancel out. And so what we're left with here is delta Q over Q divided by delta P over P, which is a complex fraction. And we can write that by multiplying the numerator, delta Q over Q, by the reciprocal of the denominator, which would look like this. And then just rearranging this a little bit so I can put the delta Q and the delta P over each other and putting the P over the Q, we will have delta Q over delta P times P over Q. Now, from an algebraic point of view, this would be the definition of elasticity. But from a calculus point of view, we want to just go a little bit further because we know that delta Q over delta P is a rate of change. And so rate of change, an instantaneous rate of change, and that's what we're going to be looking for here is an instantaneous rate of change. This can be represented by the derivative. So that would be dq dp, the derivative of q with respect to p, times p over q. And so from calculus, this would be our definition, with one more little thing to be added here. Because from the graph, we can see that delta P and delta Q, change in price and change in quantity, are inversely related. That means there's always going to be a negative relationship. Well, economists decided they didn't want to have negatives. So in order to get rid of the negative relationship, now dq dp is always going to be negative. That's going to be a negative quantity. So we simply take the absolute value of that. And if we take the absolute value of that, then what we end up with is simply the absolute value of dq dp over pq. And that is our formula for elasticity that we are going to be using for the homework in this particular section. So let's put it into action with this first problem here. So given the demand function Q equals 100 minus 2p, determine the elasticity of demand when the price is 30. So we're always going to need to have a demand function. The demand function simply tells us what the graph is going to look like. Okay? So as I discussed, we have the law of demand says we have some type of a downsloping graph. Well, the law of the demand function basically is the function that represents this graph. Okay, so we need that. All right, so we've got that. Q is equal to 100 minus 2p. Notice that it relates quantity and price, and we have price and quantity on our axes. We also have to be given one other piece of information that's usually going to be price, although sometimes it may be quantity. So to get started, first of all, let's write down our formula. Elasticity is dq dp times p over q. So the first thing that we need is the derivative of q with respect to p. So let's find that. So dq dp is equal to -2. Well, the other thing that we need is p. Well, we have that. P is equal to 30. So we have that. And one last thing that we need is q. We don't have that. But what we can do is we can use the demand function to find q. So q is equal to 100 minus 2p. So q is going to be equal to 40. So now it's just a matter of plugging it all into our elasticity formula. So dq dp is -2 times p over q. And when you simplify that, we end up with elasticity, and taking the absolute value of this, we end up with elasticity being equal to 1.5. And that is our answer. Now the question is, what exactly does that mean? So remember, let's go back to the definition. Elasticity is a percent change in the quantity demanded for a given percent change in price. So let's say that price increases by 1%. Then the quantity demanded will decrease by this amount, 1.5%. So that's really what this means. This tells you the percent decrease in quantity demanded if price increases, or vice versa. If price decreases by 1%, then the quantity demanded will increase by 1.5%. Okay, in the next problem, now that we know what all the pieces are, we can just kind of go through and do them. So I need to find dq dp, and so that will be 90 minus 6p. I also need to find q. Q is going to be equal to 90 times p, which is 20, minus 3 times 20 squared. And so q ends up being equal to 600. So we have everything that we need. We have dq dp, we have q, and we have p. So let's put it together in our elasticity formula. Elasticity is the absolute value of dq dp times p over q. So elasticity is the absolute value of 90 minus 6p. I'll put that in parentheses. Put this in parentheses, times p over q, which is 20 over 600. Now there's a little catch here, is that this formula still has a p in it. So no problem. We just substitute 20 in for that value. Just plug 20 in there. So elasticity will be equal to the absolute value of 90 minus 6 times 20 times 20 over 600. And elasticity ends up being equal to the absolute value of a -1, which then, of course, is 1. So our elasticity is 1. That means for a 1% increase in price will be a 1% decrease in the quantity demanded. Let's do one more example. Now, in this example, they specifically ask you to find demand as a function. Well, that's basically what we did here. 90 minus 6p is a function. That was our derivative. So we just have to write the derivative as a function. So first of all, dq dp is equal to 10,000 minus 100p. So that answers this question. Elasticity of demand, I'm sorry, that is just dq dp is a function. I haven't quite gotten there yet, I'm sorry. So q then is going to be equal to 10,000 times, what do we have? P is equal to 150. Minus 50 times 150 squared, and that ends up being equal to 375,000. So Q is 375,000. So elasticity is the absolute value of 10,000 minus 100p, put that in parentheses, times P over Q. And so P is 150, Q is 375,000. And then once again, we have to substitute this value here in for P. So we get elasticity is the absolute value of 10,000 minus 100 times 150 times 150 over 375,000. And that ends up, plug that into Desmos or your calculator, and we end up with an elasticity of 2. That means for a 1% increase in price, we will have a 2% decrease in the quantity demanded. All right, now I really haven't expressed elasticity of demand as a function yet. So to do that, what we have to do is write everything as a function. So I'm going to do that right here. So elasticity is going to be the absolute value of 10,000 minus 100p, and this can be considered to be over 1, times, now instead of putting in the value of p like we did up here, I'm just going to write p. And then instead of putting q in the denominator, I'm going to put in what our demand equation is, because the demand equation is Q equals 10,000p minus 50p squared. So that's going to be 10,000p minus 50p squared. Okay, so simplifying this is what we would want to do to write this as a function. So let's just simplify it a little bit. Absolute value of 10,000 minus 100p times this 100, okay, because these are all in the numerator. We get 10,000 p minus 100p squared all over denominator, which is 10,000 p minus 50p squared. All right, and that is elasticity expressed as a function. Now, the advantage to doing that is that we can now find the price elasticity for any price. I can just go ahead and plug any value of P in here, and it will give me the price elasticity. Price elasticity varies with price. It's not a constant. Now, when you're entering this answer into more, it's probably not going to expect you to put the absolute value in there. Okay, so instead of doing the absolute value, here's another little trick that you need to know for more. For doing more, instead of doing the absolute value, which remember negates this, it takes away the negative, what you just have to do is you have to multiply this answer through by a negative. So multiply the numerator through by a negative, and what that's going to do is going to give you the opposite signs, which would be 100p squared minus 10,000p all over 10,000p minus 50p squared. So this is the way they would want to do it to answer it in more. All right, so that is an introduction to price elasticity.